Oh no, I completely forgot. I still have to teach you guys about re-expressing data, Chapter 10, for AP Stats, 3 days before I graduate. What will I do?
Well, anyways, here we are. AP Stats, Chapter 10, Re-Expressing Data. Our goals for today are to 1. Make distributions more symmetric. 2. Make the spread of several groups more alike, even if they differ. And 3. Make the form of a scatter plot more linear. Re-expressing data is all about taking a scatter plot that looks like that and making it so that it will eventually look like that. You also want your residual to look completely random, as does this one, with no obvious patterns in it. Re-expressing data is used all over the world to better interpret data. For example, if you have 2 different types of species, so like 2 different types of wolves you're trying to compare data with, then it's likely that you will have to reinterpret the data in order for it to be comparable with the other. Alright, so let's go over the ladder of powers. We'll start off first with the square power. You want to try this with a unimodal distribution that is skewed to the left. Alright, next we got the raw data power, and you use this with data that is positive and negative, that has positive and negative values, and has no bounds. These are less likely to benefit from being re-expressed. Next we have the square root power. Counts often benefit from a square root re-expression. Data cannot be negative when using it. Next is the log power. It is good for measurements that cannot be negative and data that grows by percentages. Now we got the 1 over square root power. It is an uncommon re-expression, but can sometimes be useful if nothing else is working. Now we have the negative 1 over data power, and its ratios of 2 quantities, example mile per hour, often benefit from a reciprocal. So another way you can go about this is logarithms. When none of the data values is 0 or negative, logarithms can be a helpful ally in the search for a useful model. Try taking the logs of both the x and y variable. Then re-express the data using some combination of x or log x versus y or log y. For the exponential model, on the x-axis you have x, on the y-axis you have log of y. This is useful for values that grow by percentages. The logarithmic model has log x for the x-axis and y for the y-axis. A wide range of x values, or a scatter plot, is descending rapidly at the left but leveling off towards the right. The power model, log x for x-axis and log y for y-axis, is used when one is too big and the other is too small. Should you re-express the following residuals? Why or why not? Go ahead and pause the video and take a minute to answer. Alright, let's take a look at the first one here, and I would say no, you should not re-express the residual because it has no obvious patterns. It appears linear, and yeah, it has no patterns. And the second one should be re-expressed because it doesn't look random. It looks like it has a pattern. And the third one should also be re-expressed because you can see the vertical growth as it goes along the x-axis there. So here is a residual plot of the number of passengers departing from SeaTac each month since 1997. Can you account for the pattern shown here? And would a re-expression help us deal with this pattern? Go ahead and take a minute to work on that. So yes, the peaks probably have something to do with, where are we at here, the holiday travel, and the low points probably have to do with winter months after Christmas and the holidays are over with. So that's probably what causes the patterns that are shown. And yes, the data could be re-expressed because it does not appear to be completely random and has obvious patterns and it's not linear. Alright, so we're going to go ahead and work through an example here. We have world population, United Nations database, years since 1900. And here we got our data table. And it starts from 1950 and goes to 2000. So I'm going to pull my calculator that I have with me this time. On. And you're going to enter your data by hitting Stat and then going to Edit. And you're going to put the years in L1. I started at 50 and then went on from there to 2000, which ended up being 100, and then I entered the corresponding data onto L2. So once you've entered your data, you should get something that looks like this. The scatter plot is nice and straight and linear. So what we're going to do next is we're going to create a linear model for this group of data. So this is your equation you're going to use to get your your model, and it's y hat equals a plus bx. So now you know that, we're going to go to Stat, Calculate, and go down to Linear Regression, hit Enter. And while you do this, if you have your data in any different list, you're going to want to put that list next to your linear regression. So for A, you get 72.26. For B, you get negative 1,272.91. And you got a strong positive correlation. So when you get your equation done, it should look like this. You got world population hat equals 72.26 minus 1,272.9 times the amount of years. Alright, let's try another one here. This is the light intensity model. I'll pull over the graph here and you can go ahead and enter it into your calculators. It's distance candle power. So once you've entered your data, this is the scatter plot that you're going to end up with, and it's pretty clear that we're going to need to re-express it. So here's what I'm going to recommend you do. I'm going to recommend that you try the 1 over the square root of your data and see what you come up with. So what you're actually going to do is you're going to highlight list 3, and you're then going to enter 1 over square root of L2, and then your new values will come into list 3, and then you will want to go into you want to go to second y equals plot 1, and you are going to want to change this to list 3, and then you're going to graph, let me find it, zoom 9, and it worked. Should look at that. Now you're going to go ahead and create your model, and once you've done that, you can go ahead and calculate what the intensity will be at 1 foot, 12 feet, and 30 feet. Now I am having calculator issues, so basically once you get your equation, and this is not the correct equation, but all you do is plug in 1, 12, and 30 in for feet and calculate it, and then you'll get your values for each data point.